There is a graveyard in our solar system, billions of miles away, swirling inside the clouds of a gas giant. It belongs to a robot that changed everything. But before it died, this machine lived through perhaps the most disastrous, cursed, and improbable timeline in the history of spaceflight. It was a mission that survived political cancellation, the Challenger tragedy, and a catastrophic mechanical failure millions of miles from home that left it deaf and mute. By all accounts, the Galileo mission should have been a billion-dollar failure. Instead, it became the greatest comeback story in the history of NASA. It didn't just survive, it rewrote the textbooks. It turned points of light into worlds of fire and ice, and it gave us the single most terrifying and hopeful realization we've ever had. That the best place to find alien life isn't on Mars, but in the dark, cold oceans hidden beneath the moons of Jupiter. This is the story of the spacecraft that refused to die and the long, dramatic journey to the King of Planets. To understand why we fought so hard to get there, you have to understand what Jupiter actually is. It isn't just a planet, it is a solar system within a solar system. In 1610, when Galileo Galilei first pointed his telescope at Jupiter, he saw 4 faint stars arranged in a line next to it. Night after night, he watched them dance. He realized they weren't stars at all, they were moons. Io, Europa, Ganymede, and Callisto. That observation broke the universe. It proved that Earth was not the center of everything. It proved that other worlds had their own gravity, their own systems. For nearly 400 years, those moons remained fuzzy dots in our telescopes. We knew they were there, but we didn't know what they were. In the 1970s, during the golden twilight of the Apollo era, NASA decided it was time to go back. They drew up plans for a mission named Galileo. It was arguably the most ambitious robotic mission ever conceived. The plan wasn't just to fly by. We wanted to park in orbit. We wanted to drop a probe directly into the atmosphere. We wanted to see those 4 moons up close. But space exploration is never just about engineering. It's about timing. And for Galileo, the timing couldn't have been worse. The mission was born under a bad sign. Originally scheduled for the early 80s, it was hit by wave after wave of budget cuts. The spacecraft sat in clean rooms waiting while politicians debated whether it was worth the money. Then they finally secured a ride. Galileo was designed to be carried into space inside the cargo bay of the space shuttle. The launch was set. The team was ready. And then, January 28, 1986 happened. The space shuttle Challenger exploded 73 seconds into flight. The tragedy grounded the entire shuttle fleet for years. Galileo, a delicate, complex machine, was forced back into storage. It had to be shipped across the country, disassembled, inspected, and reassembled. The delay wasn't just a scheduling issue, it was a physics issue. The planets were moving. The direct path to Jupiter that they had planned for was gone. The window had closed. To get a heavy spacecraft to Jupiter now, with the weaker rockets available after the Challenger restrictions, the engineers had to get creative. They designed a trajectory that looked like insanity. Instead of flying to Jupiter, they would fly to Venus, then swing back to Earth, then Earth again. It was called the Vega trajectory, Venus-Earth-Earth gravity assist. They would use the gravity of the inner planets like a slingshot to build up enough speed to reach the outer solar system. It turned a direct flight into a 6-year odyssey through the intense heat of the inner solar system. Heat the spacecraft wasn't originally built to handle, but it was the only way. Finally, in October 1989, the shuttle Atlantis roared into the sky carrying Galileo. The probe deployed perfectly. It spun away into the dark. The team at JPL breathed a sigh of relief. The curse, it seemed, was finally lifted. They were wrong. April 1991. Galileo was coasting through the darkness, preparing for its long cruise to the outer planets. It was time to unfurl the high-gain antenna. This antenna was critical. It was a massive, umbrella-like dish designed to beam high-resolution images and massive amounts of data back to Earth. Without it, the spacecraft was effectively whispering in a hurricane. The command was sent. Open. The motors whirred. The ribs of the antenna began to expand, and then they stopped. The antenna had jammed. It was stuck, half open, like a broken umbrella in a storm. Back on Earth, the mood was funereal. They tried everything. They spun the spacecraft in the cold to shrink the metal. They spun it in the sun to expand it. They hammered the motors. Nothing worked. The friction on the ribs was too high. The lubricant had likely dried out during those long years sitting in storage after. The Challenger delay. The mission was effectively broken. Without the high-gain antenna, the data rate dropped from 134,000 bits per second to just 10 10 bits. You couldn't even send a single clear photograph in a reasonable time at that speed. The billion-dollar explorer was brain dead, but NASA engineers are stubborn. If the spacecraft couldn't shout, Earth would just have to listen harder. They began a frantic 3-year effort to save the mission. They built new, ultra-sensitive receivers for the deep space network on Earth. But the real magic happened in the code. They completely rewrote the spacecraft software from millions of miles away. They taught Galileo how to compress images, how to edit its own data, and how to trickle it back slowly using its tiny, low-power secondary antenna. It wasn't perfect, but it saved the mission. They calculated they could get about 70% of the science they originally promised. That was enough. December 1995, Galileo finally arrived at Jupiter. And despite the broken antenna, despite the detour to Venus, despite the years of delay, it delivered. The atmospheric probe detached and slammed into Jupiter's clouds at a 106,000 miles per hour, surviving temperatures hotter than the surface of the sun just long enough to tell us what the giant was made of. But the orbiter looked at the moons, and what it saw was shocking. It looked at Io and saw a world of hellfire. It wasn't a dead rock. It was covered in hundreds of active volcanoes, turning the surface inside out, spewing sulfur into space. It was the most geologically active body in the solar system, tortured by Jupiter's massive gravity. Then it looked at Europa. Galileo sent back images of a world wrapped in a shell of bright white ice, but the ice was cracked. It looked like the sea ice in Earth's Arctic. There were ridges, chaotic terrain, and few craters, meaning the surface was young. It was constantly being resurfaced. The magnetometers on board detected something strange, a magnetic field signature that shouldn't be there. The only explanation? A conductor, a fluid, salt water. The data confirmed what many had only dreamed of. Beneath that frozen crust, Europa is hiding a global ocean, a body of water up to 100 miles deep, containing twice as much water as all of Earth's oceans combined. And where there is water and energy and organic material, there is the potential for life. Galileo looked at Ganymede and Callisto and found evidence of oceans there too. It turned the Jovian system from a collection of cold rocks into a collection of potential habitats. We went looking for rocks and we found water everywhere. For 8 years, Galileo endured. It survived radiation blasts that would have fried a lesser machine. It rebooted itself when its computer crashed. It kept trickling that precious data back to Earth, bit by bit. But by 2003, the fuel was running low, the navigation thrusters were dying. The team at NASA faced a difficult choice. They couldn't leave it drifting. If a dead Galileo eventually crashed into Europa, it might contaminate that pristine ocean with Earth bacteria that had survived on the spacecraft. We couldn't risk polluting the very life we were searching for. So, the order was given, the final trajectory. On September 21, 2003, Galileo fired its thrusters for the last time. It turned away from the moons it had revealed to us and dove straight into the crushing atmosphere of Jupiter. It kept transmitting until the very last second, until the heat and pressure tore it apart. It became part of the planet it had traveled so far to see. Galileo's sacrifice was not in vain. It drew a map for the future. It told us exactly where to look. And now we are going back. In October 2024, the Europa Clipper mission launched. It is the spiritual successor to Galileo, built with modern technology, designed specifically to stare at that ice, to taste the plumes of water venting into space, and to answer the question that Galileo sparked, is there life in that dark ocean? It took 400 years to get from the first telescope to the first orbiter. It took decades of failure and frustration to get the data home. But the story of exploring Jupiter is a reminder that the universe doesn't give up its secrets easily. You have to fight for them. You have to endure the delays, the disasters, and the silence. Because when you finally open your eyes at the destination, the view is worth everything. If you enjoyed this deep dive into the history of space exploration, make sure to hit that subscribe button and turn on notifications. We have more stories like this coming soon, and you won't want to miss the next launch. Thanks for watching.